Hey Pre-Calculus, this is Mrs. Martin here with today's notes on financial models, which we'll see in a minute is very related to your exponential work that you were doing in the last video. So to start, I've got some boxes here that represent our bank account. Okay, so let's start off with some variables, because in financial models, there sure are a lot of letters that we need to keep track of. And just to make sure that we're all on the same page, we're going to label those now. So we've got P, which represents principal, okay, which is really just the initial deposit, okay, however much money you start out with, okay. We've seen this word before. All right, banks also include an R for the rate, and just so that we're all on the same page, rate is usually written in its decimal form, not as a percent. Okay, so in other words, if I've got 5%, I'm actually going to use 0.05. Okay, and then finally, of course, we need to be concerned about time. And it's important that we make sure that the units of time match our rate. In other words, if the bank is offering us an annual rate, then that means I have to talk about time in years. If I don't, for example, the Peterson activity, we went by 27 days. If I plug in 27 into my equation, I just told my equation to do that by 27 years. So be very careful, and we need to make sure that our time, again, matches the rate. So oddly enough, these are the three things that many of you asked for when we were working with the Peterson activity. You wanted to know about how much he deposited. You needed to know the interest rate that the bank was offering him. And a lot of you asked, how long did it actually take him to deposit the check? So again, principal, rate, and time, three components necessary to complete our financial model. Now I've got year zero here, and I want to talk about what's happening in the bank when we deposit some initial value. So let's go ahead and we're going to talk about, we're going to put in $1,000. Okay, here's our principal. Okay, $1,000, year zero. We're just starting out. We get our bank. We're super excited. We deposit $1,000 into a saving account. Now, and many of you might remember this from sequences in Algebra 1, when I'm ready to move on to year 2 and check my balance, I need to multiply by some amount. Now, many people like to say, I'm going to multiply by 5%. Okay? I'm going to multiply by 5% because that's the percent rate of the bank. Here's the problem with that. If I multiply my $1,000 by 5%, I get 50. And if I'm just multiplying by 0.05, it makes no sense to write 50 in year 1. We lost money. And if I was a person banking with this bank, I'd be pretty upset if my $1,000 somehow became 50. So the multiplication there isn't really working. I can't just multiply by 0.05. So let's think about what's really happening. When you multiply $1,000 by 0.05, which is my 5%, right? This is 5%. Then I get 50. But what's really happening to that 50? That 50 is an interest rate. Okay, an interest rate that is actually has its own equation for simple interest, I equals PRT. In this case, our T was just a 1 because we only went 1 year. And so what do you normally do with that interest rate? Well, thinking about it mathematically and financially, I would just take this $50 and I would add it back to the $1,000. Okay. So now I've got my principal. Plus my interest rate. Okay, but interest rate had its own simple interest formula. And from there, I can actually factor out a P. It's like that reverse distributive property that you guys talk about, right? So I'm going to factor out a P. If I factor out a P from the first term, I get 1. And if I factor out a P from the second term, I'm left with RT. Okay, so something interesting is happening here, this 1 specifically. So when I plug those things in now for the year that's passed, I get 1 plus 0.05. T is just 1 because we're only going year by year, so we can ignore T for now. So instead of multiplying by 0.05 up here, really I'm multiplying by 1.05. The rate plus the initial amount. We can talk about this in terms of testing, right? 1.05 is equivalent to 105%. And that's when you guys get 100% on your test plus the 5% extra credit. In this situation of money, this 1 refers to the $1,000. I have my $1,000 plus the 5% that my money just made on its own sitting in the bank. So now when I multiply $1,000 by 1.05, I end up with the amount that I needed, which was $1,050. Okay, so we're not multiplying by 5% necessarily, but instead we're multiplying by 1.05. Okay, the initial amount plus the 5% that the money just made by sitting in the bank. Okay, and then to continue on, I would do it again because the bank rate has not changed. And I would get 1,050 times 1.05. And I end up with $102.50. Okay, so the money's growing, and the money's growing well. So let's transfer this information into a table so that maybe we can come up with some sort of equation to show how this money is changing over extended time. The reason I need an equation is because if I ask you how much money you're going to make by the time you retire, and if you guys are, I don't know, 18 years old, that can be 50 years from now. So let's say I wanted to know, okay, your $1,000 that you deposited when you were in school today, how much money would it make you by the time you're in your 60s? It might be a pain to make a chart like this all the way to year 60. So if we can come up with some sort of pattern, which we did in the last video, that would be incredibly helpful. So let's look at that together. Okay, so if you remember from our last video about exponential equations, actually it might have been 2 videos ago, we had this generic standard form for exponential equations, right? Where C was the starting value, A was the pattern, and X is some independent variable that we're plugging in, right? So we can get that from these financial models. So let's make an XY table of the example that we were just going over. Okay, so we have T in years, so that's going to be our independent variable this time. And of course we start out with 0. And then we have, we're going to call this A for total amount. Okay, and when we started out with the principal, which was $1,000. And we multiplied by the rate, which instead of writing 0.05, we wrote 1.05 because we had to accommodate for the $1,000 that we started out with. And we ended up with 1,050. And we can do that again. And again, sorry, this is times 1.05 in case you were wondering. We're not adding, we're multiplying. Times 1.05, and we got $1,102.50. And I can keep going with this, right? I can continue to fill in this table, but really I have the information that's necessary. I have the pattern, and I have the start value. Okay, and so I can write this in to an equation. I can write A equals my start value times my pattern stay color coordinated, sorry, times time. So now when I ask you how much money you'll have in 50 years, now $11,000 sounds like a nice amount of money, but it's also given a 5% interest rate that banks don't really offer, and you're leaving it in there for 50 years. So, you know, it's just some things to keep in mind as you're looking around for how long you're going to leave money in the bank and what percent interest rate you're going to be applying it to. So let's go ahead and generalize what we just came up with. I'm going to scoot all this over. Okay. Pretty much what we've done is we've said that A equals some total amount. Let's use a different color here. Let's rainbow A. A is our total amount. And to determine this total amount, I'm multiplying the principal, or the initial value that's deposited or loaned, credit cards, all that kind of stuff. It all works the same. Here's my principal, and I'm multiplying the principal not by the rate that the bank is giving, but 1 plus the rate that the bank is giving, right? That's how we got the 1.05. If the rate is 5%, then we do 1 plus that. And then finally, we've got time up here in the exponent because we are continuing to multiply every time the rate is applied to our principal. Okay, now before I let you guys go, there is one more thing that you need to keep in mind when we're talking about financial models. And that's the fact that banks don't always apply interest annually. They often apply interest to either your credit cards or your banks, compounding at a different rate. Okay, so let's look at that. There is a situation where banks compound annually, and that means they apply the rate once a year. So we'll talk about compounding. So there's annual, where they apply the rate one time per year. There's also quarterly, where they take the quarters of the year, which means they do it 4 times per year. They break up that interest rate into 4 times within the year, which is nice because that means you're getting more money 4 times throughout the year instead of just once at the end. Okay, the more times that your money is having the rate applied to it, the more money you end up getting. Okay, because it just allows your money to grow quicker. There's also the situation where you compound monthly, which you know would be 12 times per year. Occasionally, there is the situation where you compound daily. Okay, and there's also situations like bi-weekly, bi-monthly, biannually. We're going to ignore those for now. If you ever get into finance, I'm sure you'll see those as well. We'll focus on these guys, and we're going to give all of these guys the variable n. Okay, when we use this variable n, it means that we're going to divide the rate up into however many times you're compounding, and we're also going to multiply that by the actual years that or the time that you've been given. Okay, so in other words, going back to our interest formula, I've got A equals our principal, and then we've got our rate, but this time, and I really wish the rate applied every time they compounded, but they can't. The banks would lose lots of money like that. The rate is divided amongst the number of times that they are compounding throughout the year. Okay, and given that time is given in years, that's going to tell me how many times they're going to compound. So if I'm compounding 4 times in 1 year, that means I'm going to compound my interest 4 times. If the time is over 2 years, it means I'm going to compound 8 times. So I've got to multiply the end by the number of, I need to multiply t by the number of times they're compounding, because I need to take into account that it's not just once a year anymore, it's many times a year. So if I were getting statements, right, if I'm getting bank statements, every time they compound my interest, I would get bank statements, for example, quarterly, I'd get it 4 times a year. And if I have that going on for 4 years, I'd get 16 statements. So that might be one way that you remember to multiply t times n. Okay, and so this is the formula that we're going to be focusing on as we move forward with financial models. Now it's time for us to talk about one last thing, and that's that letter E that you saw in, I think it was homework 9. E is used to represent natural things occurring. And in financial models, we use E to compound continuously. That means your bank is consistently compounding the interest on the money that's in there. Okay, and if that's the case, we have the following formula to use. We're still using the principal, but this time we're using this letter E, which again is a constant, okay, 2.17. Well, we're using the letter E to represent the compounding continuously. And this time we've got R up in the exponent multiplied by the time. So if you do run into compounding continuously, this is the equation you would have to use in order to determine how much money is now in the bank. All right, everyone, so that takes care of the material today on financial models. Please make sure that you log into Schoology and complete your ALEKS Homework 10 assignment, which should have some problems on this financial material. Please continue learning. Remember that everything you learn today helps support you in what you learn tomorrow. So I want you to keep learning, try to stay motivated. I know this is a tough time to stay motivated for school, but do your best. I look forward to hearing from you. As always, I'm only an email or a remind text away. You can message me with questions. We can meet on Zoom on Tuesdays at 10 to continue answering questions with you. Make sure you check the calendar to see what's coming up, and I hope to hear from you all soon. Take care.